We know that a function is analogous to a magic box that turns inputs into outputs. The inputs and outputs of a particular function can be mapped on a table. But what if we were to create a new function that undoes the original function? The new function would take in the outputs and turn them back into inputs. This is what it is to invert a function. By the way, this is the notation for an inverse function. Inverting a function basically swaps inputs and outputs. And inverting a function a second time returns the original function. Composing a function and its inverse just returns the original output. Since inverting a function swaps the inputs and outputs, this identity is true. Let's try graphing an inverse function. The results should look like this, since all the inputs and outputs, or x's and y's, are swapped. We can also notice that it reflects across a diagonal line. The diagonal line is formed by the graph y equals to x. The easiest way to graph an inverse function is to have x as a function of y, because the x and y's are swapped. But keep in mind, we are still going to input x and output y for the inverse function's graph. Next, the domain of a function corresponds with the range of its inverse function. And vice versa, the range of a function corresponds with the domain of its inverse function. Now let's graph this function and then graph its inverse. You notice anything suspicious? The inverse is not a function. It fails the vertical line test. The same input can make many different outputs. How could have this happened? An input making two or more different outputs. It starts with a function where two different inputs make the same output. Inverting said function, the outputs become the inputs and the inputs become the outputs. One input makes two different outputs. Now look at this function. Every unique input makes a unique output. When it is inverted, it is still a function. These functions are one-to-one. But back to this function, where two or more different inputs can make the same output. When it is inverted, it is no longer a function. These functions are not one-to-one. Let's graph a one-to-one function. Each unique input has one unique output. It passes a horizontal line test. When we invert it, it is still a function. It passes the vertical line test. Let's graph this non-one-to-one function. Many different inputs can have the same output. It fails the horizontal line test. And when we invert it, it is no longer a function, since it fails the vertical line test. Let's look at this non-one-to-one function. If we restrict the domain, it now becomes one-to-one. We can do the same for graphs. If we restrict the domain of the function so that it becomes one-to-one, where it passes the horizontal line test, And then when we invert it, we finally get a valid inverse function that passes the vertical line test. But keep in mind, there can be multiple possible domains to restrict to. Here's another example. So in this video, we've learned that inverting a function swaps the inputs and outputs. Some functions don't have an inverse function, so their domain has to be restricted in order to get an inverse function. You can go to Khan Academy to do some practice.